Hello everybody, this starts our day 5 flipped notes for homework. The type 1 warm-up is familiar to us because when we read this it says, in 2000, 179 billion liters of soda were consumed and the consumption rate has increased on average 2.9% each year since then. And notice, it gives us a function, so let's highlight that. Models the amount of soda consumed in the world. Oops, I didn't want to underline that because here it's even clearer. C of x is the amount of soda consumed in billions of liters, and T is the number of years since 2000. So it wasn't wrong to underline this, but I would have basically been underlining the same thing twice. So even though it doesn't say here define variables, we always want to have that practice. And once again, this should be T, C of T. Okay, T equals number of years since 2000, and C of T equals amount of soda in billions of liters. That is a lot of soda. So this came straight from the information we were given, and now we're going to use our model to answer this question. To know for 2015, we have to do 2015 minus 2000, this was our initial year, and we get 15. We know we will now plug that in. So we're going to say C of 15 and figure that out. Go ahead and work on that on your own. Press pause, and then we'll compare answers. Plugging in 15, I get 179 times 1.029 raised to the 15. And that gets me, let's see, 179, open parenthesis, 1.029, close it, raised to the 15. Is 274.842. If I round to 3 decimal places. We need a label on this real-world answer. If I notice, the unit of measure is billions of liters. So 274.842 billion liters in the year 2015. And we're done. If you wanted to actually figure out what this number was, just a little fun fact, you could do 274.842 times, question of the day, how many zeros are in a billion? I'm going to pause that for a second, let you think of that. Let's see if my answer matches yours. So if you're not sure, you can actually kind of work backwards. So this is 1,000. That's 1,000. That's a million. And then that is a billion. So in your calculators, let's see if we can do that. 274.842 times 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. My calculator won't even give it to me. It says times 10 to the 11th. So what that means is you're actually going to take 274.84. Even though this is not part of the question, it's good so I can help you see what the calculator means here. 2.74842 times 10 to the 11 is what my calculator said. What that means is we're going to take the decimal place and move it 11 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the zeros I'm missing. So as an answer, with 1, 2, 3, 4, 5, 6 zeros. That is what 274.842 billion looks like. That's a lot of soda. All right, stepping away from the calculator exercise, because again, this was just meant to be a warm-up on how to evaluate at 15, but I do want you to know how to understand what your calculator tells you. And fun fact on how to know how many zeros are in billions. Let's get into this follow-up question. Where did the equation come from? We're going to look at each piece of information and what do we notice? Well, the first thing that I notice is I see 179 billion liters, and I see this 179 right here. This was my initial value. This is my initial value. Now 1.029, I don't see any 0.029 anywhere, but I do see that I'm told it increased an average of 2.9%. 2.9%, to turn that into a decimal, what do? I would do 2.9 divided by 100, and I get 0.029. The rate that you're growing at is called your growth factor. And that growth factor will always be written as a decimal. So if it's growing by 0.029, why does this say 1.029? That came from doing 1 plus 0.029, which is really 1 plus the growth factor. The key to knowing why this is the way it is to realize that 1 represents 100%. So you're saying you're keeping the 100% of what you already had, and it's growing by 0.029. So let's use our rough notes here to officially fill out these pieces. Do you remember what A represents? A is always going to be the initial value. This 1 will always be there. Growth is always 1 plus R. R is our growth rate. And that growth rate will always be in decimal form. It's really important that we remember that. And I actually want to go back and edit something I just said. This is not the growth factor. This is the growth rate. It's an important difference. So apologies, but we're all in pencil, so that's fine. Let's fix this word, and then I'll explain why I'm changing it. This is the growth rate. I'm told, right? It's growing at a rate of 2.9%. 1 plus the growth rate makes up the growth factor. So there's a difference between growth rate and growth factor. If I had looked at this with you yesterday and I asked you growth or decay, you would say that B is what? 1.029. And then you'd say that's growth because B is greater than 1. So let me say it again to emphasize. The growth factor comes from 1 plus the growth rate, where we make sure that the growth rate is in decimal form. T is time, always, for these. And then finally, f of x is our output. It's a total of some kind of final amount. And I'm going to highlight this model so it stands out in my notes. This is exponential growth. The best way to get comfortable with this is to use it. We do have one little important note to write down before we practice, and that note is before using the model, to answer a real world problem, add 1 plus r first. To get a single number inside the parentheses. If you need a second to write that note down, go ahead and press pause. We're going to get right into our first practice question to really tie all of this together. We try. UConn's tuition has risen 5% each year since 2000. If the tuition in 2010 was $20,006, write an equation for the amount of tuition T years after 2010. Predict the cost of tuition in 2016. Now here I see I have no equation to highlight, meaning we have to write our own. This entire lesson is on growth. Another way for you to know that it's growth is this word, this keyword right here, risen 5%. So just like before when we were working on characteristics, I had you write the general form. We are going to write the general form for growth at the top every single time. So it's f of x equals a times 1 plus r raised to the x. If you want to use t instead, you could. It's fine either way. F of x equals a times 1 plus r raised to the x. We need all of these pieces. But before we look for those pieces, let's define our variables. I see here that it says T years after 2010, and write an equation for the amount of tuition. That's going to be my total. So T is going to be number of years after 2010, and F of T is amount of the tuition in dollars. We've defined our variables. Now let's get pieces. So for this model, if you really think about it, you only need to get two values. You need to figure out what A is and what R is. So let's go find A. Remember, A is our initial value. So our initial year was 2010. What was the tuition in 2010? in 2010. I'm told right here that was my tuition. I want you to circle it, and I want you to label it A. And if it's helpful, you can even make a note right here. A equals $20,006. I also need my growth rate. So this was initial value. Now I need to go find my growth rate. I'm told that tuition rises 5%. That's R. But remember that note that we wrote to ourselves at the bottom of the first page? One, we're going to have to do some addition, and then also at the bottom we wrote has to be in decimal form. So to get a decimal, 5 divided by 100 is 0.05. That's what we're going to use for R. We've got A, we've got R, we can now start writing our model. So it's going to be f of t equals 20,006 times 1 plus 0.05 raised to the t. All we did just now is take this general model and fill in what we had for A and what we had for R. That's all we did. Now that note that's at the bottom that says we have to add this first, that's what this means. Before we actually use the model, go one more step and actually add that together to get 1.05. Just one number inside parentheses, and I have my model. Now that I have my model, I can go use it. I was told to predict the cost of tuition in 2016. Well, 2016 is how many years after 2010? I hope everybody says 6. So that's what I'm going to evaluate. I'm going to find f of 6. Pause the video, please, and you finish finding f of 6. Find tuition at UConn in 2016. So we're going to do 20,000 times 0, 0. Did I throw in an extra? Ooh, just saw that. I got happy with those zeros and I threw in an extra one. Let me fix that. Ah, I did it right here too. Sorry about that, guys. Okay, problem solved. So $20,006, there we go, times 1.05 raised to the 6th power. Calculator refresher, I'm going to type in 20,006, parenthesis 1.05, caret 6. And when we do that, I got $26,809.95. It's technically 0.953, so to round that to money, 0.95. I'd like us to get back in the habit of writing a concluding sentence. So we were told predict the cost of tuition in 2016, so we can actually use that to write our sentence. The predicted cost for tuition in the year 2016 is $26,809.95. $26,809.95. And we are done. This process doesn't change, so it's now time for some practice. These next two are labeled as independent practice. I'm going to help you with half of number 1 and then want you to finish. And then number 2, I'm going to challenge you to do all by yourself. number 1 says, Oscar was just hired as a linesman to work on power lines for Eversource. His starting salary is $38,000, and according to his contract, he'll receive, I think that's a typo, ignore that, 1.8% increase in his salary every year. How much will he earn in 20 years? Again, this entire practice is under the title of exponential growth, but I also know it's growth because it says 1.8% increase. Don't overwhelm yourself with trying to think of everything at once. The first thing we want to do is define our variables. I don't see any mention of a 0 year, but I know that his salary is increasing every year. So X will be number of years, just in general. I'm not told a starting year. And then think big picture. What total is being discussed here? This entire question is talking about what? It's talking about how much money he makes. So Y, or more specifically, maybe let's use f of X, is his salary. What comes next? We've defined our variables. Now what? Well, ultimately, I'm trying to answer this question, but no model, no work. We've got to get the model. So off to the side somewhere, remind yourself what's growth. In general, f of X equals A times 1 plus R raised to the X. Or you could say f of t, and then that would be t. This is what we're shooting for. Remember, to use this model, all we have to do is accurately identify A and R. So please read for information right now. I want you to tell me what's A and what's R. I'm told right here his starting salary is $38,000. That's A. Circle it and label it A. I'm also told that he'll receive a 1.8% increase in his salary each year. There's my rate. That's my growth rate, 1.8%. But remember our note, the growth rate has to be in decimal form. So how do I get 1.8% to be a decimal? Hint, what do I divide by? To get this percent to be a decimal, we have to do 1.8 divided by 100, which is 0.018. A strategy to do this without a calculator, dividing by 100 is the same as moving this decimal place to the left twice. See, 0.018, 0.018. If you followed me there, that's great. Use that strategy. Otherwise, you can always just take your calculator and do 1.8 divided by 100. I've got A, I've got R. I'm ready to write the model. So we're going to follow this right here. F of X equals A, which is 38,000, times 1 plus 0.018 to the X. So all we did was plug in A and R in decimal form. Really think about what this means. He's going to, from year to year, his salary is increasing. So he's going to make 100% of what he made last year plus 1.8% increase. 100% as a decimal, so to speak, is 1. 1.8% as a decimal is 0.018. So mentally think of this as 100% of what he made last year plus the increase in his salary, all in decimal form. Before we can use this model, we need to add these two numbers together. So f of X equals 38,000, that's not changing, times 1.018 to the X. And now I've got my model. We can use it. I was asked how much will he earn in 20 years? There was no 0 year to account for, so you can actually just straight up plug in 20. So go ahead and calculate f of 20. If you need to, kind of draw a line to separate your work, the model, from your work. For me, I think this is going to get in the way. So I'm going to, while you work on that, I'm going to move this. So wherever we saw x, we plugged in 20. Typing this into the calculator, 38,000 times 1.018 raised to the 20th power. I get that he's going to make $54,292.41. It's technically 0.414, so I don't round the 1 up. Our sentence, we were asked how much will he earn in 20 years. Let's turn that into a statement. In 20 years, he will earn $54,292.41 per year. It's a pretty nice jump in salary. When he started, his starting salary was $38,000. 20 years later, he'll be making $54,000. And we're done with number 1. Now, I did a little more talking than I had intended to on number 1, so I'm really going to try to make sure that you guys try 2 all by yourself before I talk about it. I'm just going to read it through with you to make sure we're on the same page. It says Spotify was launched in 2008 and had 1.5 million memberships by the end of that year. 1.5 million is the same, written out is 1, comma, what you see here. The number of memberships sold has increased on average 28% each year. Write an equation for the number of memberships Spotify has sold T years after 2008 and use it to predict how many memberships Spotify will have in 2016. So the only thing I'm going to say is that for A, Spotify was launched in this year. Use this. Now press pause and truly try this, please. Really, really, really try this by yourself. When you're done, as far as you can go, hopefully all the way to the final answer, we'll compare. And you are going to get a big number. I'll just let you know that. When you come to the point of answering the real world question, it'll be big. Press pause, try it yourself. If you're listening to this part, I hope it means you genuinely tried it by yourself. So what I underlined is T years after 2008, and I have to write an equation that models the number of memberships in general. That's my total. So T is number of years after 2008, so I do have a 0 year here. And F of T will be number of memberships. At any point, by the way, if you got stuck, like for example, if you didn't know how to define the variables and so you couldn't keep going, pause it now and you keep going. After I define my variables, I can't go any farther until I have a model. I'm told it's increasing, so I know it's growth. So I'm going to write my little growth model here. F of t equals A times 1 plus R to the t. To use this model, I have to find A and I have to find R. That's our job. right now. So in 2008, I know that there's this many members, that's A, and increased an average of 28%. There's my R. A equals 1,500,000, and R is 28%, but I can't use it as a percent. I need to divide by 100, and I get 0.28. That's what we're going to use. If anybody was moving the decimal point, 28%, the decimal's right here, move it twice to the left. 1, 2, 0.28. Again, if you don't like that, that's fine. Divide by 100, you get your decimal. We're now ready to write the model. So writing the model, this will become f of t equals A, which is 1,500,000, times 1 plus 0.28 raised to the t. Before we use it, we have to add that together. So f of t equals 1,500,000 times 1.28 raised to the t. Now that we have defined our variables, we've built and simplified our model, we can use it to answer this follow-up question. It said, how many memberships will Spotify have in 2016? I do have a 0 year, so I have to say to myself, well, how many years after 2008 is 2016? If you didn't already know that was 8, you could always go back to subtracting. And I know that I will be substituting in 8. So let's do that. F of 8 equals 1,500,000 times 1.28 raised to the 8th. It'll be interesting to see how far the calculator lets me go with this. Let's see. 1,500,000 times 1.28 raised to the 8. Hey, it let me do it without giving me any of that 10 to the E thing that came up in the warm-up. So I'm just going to write it, and then I'll decide where my commas go. 108,086,39.11. Let me check. 108,086,39. Commas, you start here and then every 3. 1, 2, 3, comma right there. 1, 2, 3, comma right there. Now this represents memberships. We can't have 0.11 memberships. So the real world meaning of this will be 10,808,639 memberships in the year 2016. And you're done. That wraps up our class notes, and your flipped homework for tonight ends here. The practice, the homework for this lesson, we will be doing in class tomorrow. So go ahead and stop here. If you have some time and you want to give those a shot, you're more than welcome to try. Great job. Any questions on the notes, please send me a remind, and I will get back to you. Have a great night.